So using a flow chart, remember to pause this video whenever needed to copy this stuff down. So first off, if I was going to take the fact that B is the midpoint, B is the midpoint of AD, tells me that AB is congruent to BD. And the reason is midpoint tells me two congruent segments. Next piece of given information tells me that I have right angles, so I need to state that as well in my proof. And I know that because two angles are right angles, I can say that they are congruent to each other. And so I can say right angles are congruent. So I have two pieces of information. The other piece of information that I have is the same side here. CB is a part of both of them. So I need to say that CB is congruent to itself because I need to have that side a part of my proof. But I will say that it's congruent to itself, and that is the reflexive property. And then I can see in my proof that I have a pair of sides marked congruent with the angle included between them. So that tells me that I have my congruent triangles. And that is because of side, angle, side. Another one here, we're going to do a flow chart instead for this one. I'm sorry, a 2-column, my mistake. So for this one, when I start with the fact that DH is parallel, so the fact that DH is parallel, that tells me with these parallel lines along my transversal, I'm going to get that angle D is congruent to angle G. And that is because parallel lines tell me that alternate interior angles are congruent. I'm then going to use my next given, the fact that DE is congruent to EG. And then something else that I can take from the diagram is the fact that I have vertical angles. So I can say 1 and 2 are congruent. And that's because vertical angles are congruent. So now when I look at my diagram, I have two pairs of angles marked congruent and the side that is included between those, which tells me that my triangles are congruent with two pairs of angles and the side included, which is angle, side, angle. We can do the same concept with parallel proofs. Paragraph proofs. So looking at this diagram, I'm pretty close to having what I need here, except for the fact that BC and DE are not sides of my triangle. They're close, they're partial sides, but if I include this CD part to each side. So start off with we are given AB is congruent to FE. AD is congruent to FC. I know it does seem tedious, but we do need to state our givens. We need to bring in the reflexive property. So by the reflexive property, CD is going to be congruent to DC. I need to bring in that same segment. And then when I add CD, to BC and ED, so using the addition property, then I can say that BD is congruent to CE, which then allows me to say by side, 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 because now that I have all of the sides marked congruent, then triangle ABD is congruent to triangle FEC. For proof number 4, we're going to prove triangle ABC is congruent to triangle ADC. Let's start with our first given. Let's do this as a 2-column. Now, if I say that I have my pair of sides marked congruent, and then if I say that AB is perpendicular to BC, I'm going to go ahead and just say what that tells me next, which is the fact that angle B is a right angle. And then my next one, my other perpendicular statement, and that tells me that angle D is a right angle. I know that because I have 2 pairs of right angles, I can say that the right angles are congruent to each other. And so now I need to look at my diagram and figure out where to go after that. The only other piece of information I can use is the fact that I have AC, which is in both triangles. So when I bring AC in, I need to make sure that I say that it is from reflexive and then looking at my diagram, I have 2 pairs of sides marked congruent and then an angle. And that's not allowed unless it is RHL. And I have a right angle, I have the hypotenuse, and then I have the leg. So these 2 triangles are going to be congruent by RHL. And so I will list that as my 8th step. Triangle ABC is congruent to triangle ADC by RHL. There are 2 proofs left. The first one, when I look at, you're going to write this proof on your own, but when you look at this one, we have the fact that angle B is congruent to angle E, angle C is congruent to angle D, and then we have marked this side. We have everything given to us, and it's 2 angles in a row, and then the side that is not included. So we're going to need to use angle, angle, side to write this proof. And then the last proof is going to be a little bit longer. But when you finish this one, we need to say that triangle ADB is congruent to triangle ADC. Go ahead and finish that proof, and then you guys can check your answers later.